Good evening everyone. Let's make this video fun. I am Mr. Ish. Thank you for joining me. We're looking here at an interesting function fact. It has very much to do with composites. If you have a function and you have its inverse, you do f of that inverse, you'll always end up with x. In other words, if you do f of minus 1 x, you'll always end with an x. The inverse is feeding into your original function and you'll always get the x. We don't have to prove this, we just have to show it because we're trying to make this fun. Let y equal x squared. What's the inverse of this? This you know is your function f of x. What's the inverse? You switch the letters around. X is equal to y squared and then y is equal to root x, which here is your inverse. Remember the procedure for doing an inverse? Now we're doing f of the inverse x. We'll have this inverse root x go very much into your original function. You'll have a root x going into your square, and what are you going to end up with? X to the 1 over 2 to the power of 2. You'll end up with the x. You can calculate that for yourself and you'll see it to be the case. We can make this quite a bit more fun by looking at more of such examples. This is a very good finding to know. Let y equal sine x. This right here is your original function f of x. What's the inverse of this? If y is equal to sine x, you flip the letters around. X is equal to sine y. You solve for the y is equal to arc sine x. Arc sine x is your inverse right here. You're doing basically this procedure right here. This is going to feed right into here. You're going to be looking at sine of this arc sine x, which is really an x over 1. Think of a triangle right here. Here's your theta pointing in that direction. Based on this definition, sine is opposite over hypotenuse. You can fill this out, you don't need to. And now you're looking at sine of this angle, theta. Sine of this angle is x over 1, which is x, and here it is. It's always going to equal x. But let's look at some more examples, because we want to make this a good learning experience, a good function fact that you should always remember. How about this? If y is equal to e to the x, which is your original function, what's the inverse of this? Switch the letters around. X is equal to e to the y. Solve for your new y, right? You're going to bring it here and bring in the natural logs. Y ln e is equal to ln x. This ln e is equal to 1. So y is equal to ln x, which right here is your inverse. Your original function has an inverse. E to the x has the inverse. It's natural log x. So you're putting everything here. You're basically looking at e, which is your original function, to the ln x, and you know by means of a logarithmic identity this is always equal to x, and it's shown. If you don't believe me that it's equal to e to the ln x is always equal to x, you can show it. And I've presented a logarithmic identity video showing just this. Right here, y is equal to e to the ln x. Bring the natural logs. Ln y is equal to ln x. You're bringing this right here. Ln e goes away. Bring everything on one side. Ln y minus ln x is equal to 0. Bring this under a common log, quotient of their values, ln y over x is equal to 0. Take the natural log on the other side is equal to e to the 0, which is equal to 1. Take the x on the other side, y is equal to x, and here it is. So any function, if you put within that function its inverse, you'll always end up with an x. Not a 1, but an x. That's something you gotta remember. Some people confuse it, or some students confuse it, and they think that you do a function, a composite with its inverse, you'll get a 1 over here. That's not the case. You'll always get an x. Let's look at just a few more examples and we'll be done with that. Let a original function f of x equals y, which is equal to cube root of x. What's the inverse of this? Well, you'll switch the letters around. X is equal to cube root of y, which is the same thing as you looking at y to the 1 over 3. You have to solve for the new y. Y is equal to, you take the cube root on the other side, it becomes x cubed, which right here is your inverse. Now you're putting everything in here. The inverse function is feeding into your original function. You have a cube root of this x cubed, which is x to the 3 over 3, which is x to the 1, which is x. So you'll always end up with an x, not a 1, but an x. An original function into which you are feeding its inverse will always give you a value x. With regards to whatever variable, if you're looking here everything with regards to y, like you're looking at y as your main variable, then you'd always be getting y. But we're so used to looking at x as our variable. How about this last one right here? Let y is equal to 3x minus 5. This right here represents your original function f of x. Find its inverse. Switch the letters around. X is equal to 3y minus 5. Solve for the new y. X plus 5 is equal to 3y, and y is equal to x plus 5 over 3. which you know to be now the inverse of the original function. This inverse is going to feed in right here into this place of x, because it's the inverse going into your original. See, inverse is going into the original. You'll have 3 times x plus 5 over 3 minus at 5. These cancel out. You'll have x plus 5 minus 5, and the 5's will cancel out. You'll just have x. So again, you're showing it. So the interesting function fact or the finding is this: if you have an original function and you do its composite with its inverse, you'll always get an x. Not a 1, but an x. And you can look at it as this way: the inverse of your original function is feeding into your function to give you your x. And that's it for this video. Remember, this fact is very important, very interesting. Thank you for watching. Have a nice day.